If you've ever wondered how artificial intelligence can turn a simple sentence into a vivid photograph, a stunning piece of artwork, or an entire imaginary world, you're not alone. Text-to-image AI has exploded in popularity, but the technology behind it still feels like a secret magic trick. Today, we're going to break open that mystery. We'll explore how these systems think how they learn, and how they transform pure noise into something meaningful. This is a deep dive you've never heard before, explained in the simplest way possible. So sit back, relax, and let's uncover how AI image generators really work. Have you ever typed a short sentence into an AI tool and watched it magically turn into a photorealistic picture? Something like a cat wearing sunglasses, surfing on a slice of pizza. And somehow, within seconds, the AI gives you an image so crisp that it looks like it belongs on the cover of a bizarre comic book. But what exactly is happening inside these systems, like Midjourney DALL-E and Stable Diffusion? Today, we're going to peel back the layers and walk through a world where machines learn to see, understand, and finally create images from pure noise. By the end of this explanation, you'll understand how text-to-image models actually work, why they're so shockingly good, and what strange tricks they use to turn a messy cloud of random pixels into beautiful structured art. Let's start with something surprising. When you give AI a prompt, it doesn't immediately start drawing. It doesn't even know how to draw in the way humans do. Instead, the very first thing it tries to do is understand the words you typed. Not in a poetic sense, not emotionally, but mathematically. For AI, every word is just a cluster of numbers. For example, the word cat might turn into hundreds of floating point numbers, like 0.32, 1.11, 0.87, and so on. This long chain of numbers is called an embedding. You can think of it like the AI's internal GPS coordinates for meaning. If cat and kitten have similar numerical patterns, the AI understands that they're related. If cat and spaceship are very different, the AI knows they're far apart conceptually. So now the AI has a numerical understanding of your prompt. But here's the twist. Instead of taking a blank canvas and trying to paint your idea onto it, the AI does something that feels almost backward. It starts with noise. Literal random static. The visual equivalent of TV snow. Completely chaotic. No shapes, no meaning, nothing recognizable. Why would an image generator start with something so messy because of how it learned? The secret behind these models is a technique called diffusion. Imagine taking a real image and slowly adding noise to it, little by little, until it becomes unrecognizable. A cat turns into a fuzzy blob. A human face dissolves into static. A house melts into a gray cloud. Eventually, after enough steps, all that remains is pure randomness. During training, the AI sees millions of images being gradually destroyed by noise. But here's the clever part. At each step, the AI is asked to predict how to reverse the damage. It learns to take the noisy image and guess what the cleaner version looked like. Do this millions of times, and the AI becomes an expert at the reverse process, turning chaos back into clarity, turning static back into a cat, turning noise into structure. It's like learning how to rebuild a sandcastle after watching thousands of sandcastles collapse in slow motion. So when you give it a prompt, the AI says, "Great, I know what these words mean. I know what a cat is, and I know how to turn noise into a picture. Let's reverse engineer this static until it matches the idea you want." And that's where the magic happens. Bit by bit, the AI removes noise from the random cloud of pixels, sculpting shapes, refining details, aligning colors, all guided by the meaning of your text. But this raises an important question. How does the AI know where to put each thing? How does it know that cat wearing sunglasses means the sunglasses go on the cat's face? Or that flying ship in a neon city means the ship should float above buildings glowing with bright lights? The answer is a mechanism called attention, more specifically, cross-attention. Think of it like a constant conversation between two brains inside the model. One brain understands language, and the other understands images. During the generation process, these two brains check in with each other thousands of times. When the AI is unsure what a blob in the image should become, it looks back at the text. Should this curve belong to the cat's tail, or to the surfing board, or maybe part of the background? The attention system helps the AI map words to regions. In simple terms, the AI keeps asking, does this pixel relate to this word? And it refines the image based on those answers. It's an incredibly dynamic process. The AI doesn't place objects like a human illustrator. It doesn't sketch the outline first and fill it in later. Instead, it repeatedly transforms the whole noisy image through dozens or even hundreds of steps. Every pass makes the image a little clearer, a little sharper, a little more aligned with your prompt. It's like watching a Polaroid develop, except the image is not pre-existing. It's being invented on the fly. But here's something most people don't realize. The AI isn't inventing things entirely from scratch. It doesn't dream up cats and castles out of nowhere. It learned by analyzing billions of real images collected from the internet. From those images, it learned patterns, what cats generally look like, what castles look like, what anime style looks like, what oil paintings look like. When you say a castle in watercolor style, the AI isn't copying a specific image. Instead, it has internalized the general visual pattern of castles and the general pattern of watercolor. Then it combines those patterns mathematically to produce something new. This is also why AI image generators are so good at matching styles. Want to picture an anime style? The AI remembers mathematically that anime often involves large, expressive eyes, simplified shading, and smooth color transitions. Want something that looks like an oil painting? The AI has learned that oil paintings tend to have thick textures, visible brushstrokes, and warm layered tones. It doesn't need to reference specific artworks. It has absorbed the visual language of each style during training. But sometimes the AI makes mistakes funny weird, or even slightly creepy mistakes. Extra fingers, melting faces, hands that look like bundles of spaghetti. Why does this happen? The answer is actually simple. Human hands have incredibly complex geometry with lots of variation. They appear in countless poses and lighting conditions in photos. During training, hands often get partially occluded, blurred, or cropped. As a result, the AI doesn't learn a perfect, consistent pattern for them. When the model tries to reconstruct a hand from noise, sometimes the noise wins the battle, and you get 5, 6, or 7 fingers. Bias can also creep in. If the training data contains more images of certain demographics, certain professions, or certain settings, the AI may overproduce those results. This isn't because the AI prefers anything. It simply reflects the patterns it has seen most frequently. This is one of the biggest limitations of text-to-image systems today, and improving this is an active area of research. Now, let's address a question people often ask: is AI creating art? Or is it just remixing what it's seen? The truth is somewhere in the middle. The AI doesn't retrieve or copy existing images, but it's also not creating from a blank slate like a human artist with imagination and intent. Instead, it blends statistical patterns from its training data to form something that's both familiar and brand new. It's a bit like learning a language. When you write a sentence, you're not copying a specific sentence you've seen before. You're using your knowledge of grammar and vocabulary to assemble something unique. AI does the same thing, but with pixels instead of words. So what about the future? Where are these systems heading? We're already seeing hints. Text-to-video is improving at astonishing speed. Soon, you'll be able to describe an entire scene, and AI will generate a short film based on your prompt. Real-time generation might allow you to modify images or videos on the fly simply by describing what you want. Tools like ControlNet already let you guide the AI using sketches, poses, depth maps, or even rough layouts. It's becoming less about typing a prompt and more about collaborating creatively with the machine. And here's something even more fascinating. These models might soon be able to generate entire interactive worlds, virtual environments, dynamic characters, personalized scenes, crafted from nothing but your imagination. Instead of drawing a character for your comic, you might simply describe them, and the AI could render them in hundreds of poses and angles instantly. Instead of designing a game level manually, you might just tell the AI, "Give me a cyberpunk city with layered rooftops, neon alleys, and a rainy night atmosphere," and it builds it for you. Statement by statement, idea by idea, the boundary between text and creativity keeps shrinking. But for all the complexity under the hood, the core idea remains beautifully simple. These AI models know how to turn disorder into order. They take a cloud of randomness and carve meaning out of it. They transform noise into structure. They do, in a mathematical sense, the reverse of entropy. And that's why this entire field feels so jaw-dropping. With just a few words, you're not just asking an AI to draw. You're asking it to unwind chaos into coherence, to reverse destruction into creation. So the next time you type a prompt into an image generator, remember this. You're not just giving the AI instructions. You're giving it a puzzle, a riddle, a challenge to rebuild the universe from static. And with every pixel, it reveals you're watching one of the most remarkable tricks in modern technology unfold, turning noise into art, one mathematical brushstroke at a time. Thanks for watching. If you enjoyed this explanation and want more deep dives into how complex things actually work, make sure to stick around for the next episode. There's a lot more to explore, and we've only just begun. And that's the true story behind AI image generators. What seems like magic is actually a beautifully structured dance between language mathematics and patterns learned from the world around us. If you enjoyed this explanation and want more plain, clear, fascinating breakdowns of complex ideas, make sure to subscribe to the channel and stick around for future episodes. There's so much more to uncover in the world of AI science and technology. Thanks for watching, and I'll see you in the next one.